Okay, so we're going to look at 90, which is a complex fraction. Yeah, I didn't like the white with the black background if you watched the previous video. I'm going to stick with the black background and some type of color. I think it stands out better on my eyes when I look at my laptop. When I look at my computer desktop, it's the other way around. But I'm going to go with this. But anyway, problem 90, as I write it out here and babble about color schemes, is this complex fraction. Now, already the bottom has a denominator. So I'm not going to worry about the bottom part of the division. What I'm going to do is I'm going to get the common denominator upstairs first and work on the upstairs. Then I'll turn it into the multiplication. So I am going to multiply this denominator by this denominator. But I'm going to do it in the form of 1. So I don't change the quantity. Right, just change how it looks. Anything multiplied by 1 is still itself. So I'm going to change how it looks. Going to do the same thing here. You should note they now have the same denominator. So I'm going to be able to combine the numerators. And this is still x squared minus 1. All right. So let's combine the numerators. I'm going to come up to here. And so I get 3x minus 3. And my minus sign is going to distribute. So I'm going to get minus 3x and minus 3 again. Right? Minus 3x minus 3. Yep. Distributes through. But we now have a common denominator of x minus 1, x plus 1, all divided by 5 over, well, now I'm going to factor this because I want to get my restrictions, right? Alright, so my restrictions are x can't equal 1, nor can it equal negative 1. Right? If it's 1, that's 0. If it's negative 1, that's 0. So now I'm going to gather my like terms here. So 3x minus 3x is 0. These two. And negative 3 minus 3 is negative 6. So I get negative 6 over x minus 1, x plus 1. All over 5 over x minus 1, x plus 1. Now I'm going to show you a trick here. If you do further on in certain economic problems, certain physics problems, certain red tech problems, certain population models, you'll get fractions of fractions like this. If the denominators are the same, they'll cancel. And if the numerators are the same, they'll cancel. And in this case, these denominators are identical. So this is going to give me negative 6 over 1 divided by 5 over 1, or negative 6/5. And so this always equals a number as long as x isn't 1 or negative 1. And what I would like you to do is to turn that denominator into an inverse and do the multiplication and see that the canceling does happen, that these things do cancel. But if you see these terms being the same, they'll cancel. Well, what's that look like, right? So I'm going to turn it into a multiplication. Negative 6 over x minus 1 times x plus 1. Let's flip this. X minus 1 over x plus 1 all over 5. And notice how it did exactly what we said it was going to do, equals negative 6/5. Now that's a pattern that happens enough that you can save yourself a step if you see it. If you don't see it, keep doing the steps. Turn the division into a multiplication. Turn the division into a multiplication.